Thank you. Nice to be here. So, I guess, first of all, why should you trust me? I guess one thing is that I do have a microphone. And the other, you probably used one of my projects, so maybe many things go anonymous on the internet. Yeah, so it's this GIF, or GIF, depending on what you like. Anyways, so first, serious disclaimer. It may cause analysis paralysis. So use these advice in your day-to-day work with caution because it's a huge time sink. Anyways, a little backstory. I quite often do mentoring, which is, and I have two go-to exercises. And today we're going to talk about one of them, which is the infinite possibilities. It's a really simple exercise to state. You take a really simple problem. Let's say you want to convert from Celsius to Fahrenheit, right? Everyone knows how to do that. And then you write it in 15 different ways, or more if you're more experienced. And finally, you analyze what's good and what's bad about them. So the goal isn't to actually write this 15 different implementations, but to cover the whole design space of how code could be and can be. And why this exercise? People are animals of habit, I would say. And if you don't intentionally break out of your habits, then you don't discover new ways of doing things. It's also good exercise because it scales up to your skill level. Every additional solution will make it more complicated. And as an part of engineering, the way you can make trade-offs is if you have different solutions that have different trade-offs, right? So you do need multiple solutions. And of course, design requires constant exercise. Otherwise, you'll only grow when somebody tells in code reviews, oh yeah, you should do this better because that's better. Yeah, makes sense. So how do you approach this? Let's say you've written 5 implementations. I know everybody here would do 20 already, so easily. But let's say you only got to 5. So first thing, relax. Stress and trying to come up with new ideas is kind of a blocker for creative thinking. Stop judging yourself. You can do bad things during this period. So any idea that comes to you goes. You can later decide what to keep, what not to keep. And finally, then you take those solutions and you start to vary them in different ways. Either pushing them in some way or applying some code substitutions. Or find related examples, which I wouldn't recommend initially until you have 20 or 30 versions of it. Otherwise, you'll lose the otherwise the exercise loses its purpose. And finally, you can judge, right? And we're going to focus on these things. I'm not going to talk about judging or what's better, what's worse. I'm just going to talk about what you can do differently, right? So this is how it's structured. I'm going to talk about first what I mean by a code dimension, then a bunch of philosophical questions, and then I'll show some code substitution examples, and finally, how would you apply it in practice in designing a flow-based programming API that I never designed, right? So what makes a code dimension? I've given a few examples here. This is the small list. There's probably 10 times more of those that you can figure out. Each of those can be a separate talk or multiple in it of themselves. So, and what we want to do with those dimensions is we want to stretch them. We want to push them to the extremes. So we don't just want the better approaches, we want the worse examples as well. Because in the worse examples, that's where the discovery lies. Like you realize something that you didn't know before, right? And usually when you know the worst bad parts of things, then you know much better what are the good parts. And of course I say dimensions. They aren't dimensions, they are like multiple branching points that how different designs can be. So, and you might assume that, oh, there's a linear relationship between those different things. So if you make something really efficient, then the readability goes down, right? You do some low-level optimization stuff. Reality is more like this. So you have this, initially, when you increase readability or efficiency, both increase at the same time, because you kind of get rid of the graft, right? And at some point, performance, let's say optimizations, will start to make the code harder to read again. So, and yeah, of course I say dimensions, it's just subjective, missing nuance, and so many other things. If you want to fight about the definitions later, yeah, sure, why not? And we want to think about who is going to be judging like the solution. Like we cannot just stay in our own perspective. We need to think about like the beginner perspective and the expert perspective. Like the comments that the beginner needs and what the expert needs are different, right? So there are many people you could target. So this is how I'm going to present my dimensions. At the top there's some category, some dimension, and a short description to get the gist of it. On the left, there are some examples. I won't talk about the examples, those are just for reference. And then on the right, there's a pretty picture for entertainment. And yeah, so let me guide you to code meditation, sorry, mentoritation. So imagine the last code you wrote, and we're going to now start playing around with that piece of code. So let's look at your code readability. Let's start at your code, line 1, whatever it is. And so how can we make it prettier? How can we make it more understandable? So what makes code readable? Why is your variable naming good? Like, what would happen to your code if you spent 5 hours on just fixing and improving your naming of things? I've seen many improvements from the code structure if you get the names right, right? And on the counter side, like, how far can you push back on making the code unreadable, right? What makes code unreadable for people? Like, what are the idioms? What does an idiom mean even, right? I won't answer them. As I said, it's a meditation. So, how do you organize your code? Like, how can you structure different things, and what should you put together, what you keep apart, right? What's locus of attention? Like, what's chunking? How do they relate to code structures, and how can you make your code structure that it supports your program better, right? Conciseness, there's no intrinsic value maybe in conciseness, but let's say you wanted to do 100 times reduction of your code, like make it 100 times shorter character-wise. What would happen to your code? I'm sure you would discover a lot of powerful abstractions that can be combined in different ways. So Viewpoint Research Institute did a STEPS project which ended up with less than 20,000 lines of code to implement document editor, graphics pipeline, compiler, and all in 20,000 lines of code, right? Or less than, actually. So, and of course we've seen, like, in Russ's talk about the testing, there was essentially custom DSL for writing test scripts. We've just had a talk about writing custom language for a certain purpose. Ease of use, of course. Like, what makes code easy to use, or packages? Like, how can you make your code easier to use? Of course, like, there's also the part of simplicity of implementation. How do ease of use relate to simplicity of implementation? Like, if you make your implementation as simple as possible, will it eventually start making the ease of use worse, right? Or vice versa. Of course, we need to talk about mental models. Like, you've been thinking about this problem or the code in a certain way. What if you changed your thinking from object-oriented or to functional or data flow or logical programming? Like, you would discover entirely different solutions, and why would one be better than the other? And of course, domain. Each of these domains will require different solutions eventually. We can talk about efficiency now. Like, we've covered already, like, just the clarity part, but let's make it better. Let's make it fast. So we need to ask, like, where is it going to be better? Because a test or benchmarking your code on 1 megabyte data file doesn't represent what it will do on 1 petabyte file, right? So, of course, the simple answer is look at ON complexity. But reality isn't that simple. You can model like cache interactions and stuff in O notation as well, but it's not usually. But you can start to push the boundaries of how fast does your code go, right? There's, maybe you push it to chip entirely. And of course, we saw the Bloom filter talk. Like, he knew exactly how much memory everything used, I would assume. Yeah? Okay. Do you know how much memory your program uses exactly? Like, where is your main bottleneck? What would happen if you reduced your memory size usage 100-fold? Like, how much faster would it go? Would it go faster at all? There's a relationship with, like, the less data you have in RAM, the more likely it's going to end up in a cache, right? We can also look at stability. So we saw the talk about JWT and the errors they made in their API design, right? How can you ensure that this doesn't happen with your code? Like, how can you prevent people from using your code wrongly and introducing security issues? Or you can look at fragility. Like, how likely is it to break your code if you make a small mistake? Like, fragility in it of itself isn't maybe a problem, because many consensus algorithms are like intrinsically fragile, but they do give a lot of benefits as a result. And fault tolerance. Like, how do you cope with failure? Like, in life, in code. So, anyways, there's also adjustability. Like, how flexible is it, your code, to make it do new things? Or how easy is it to add new things to it? That's the part of finishing the meditation. Okay, so I want you now to think back. Like, there's so many different things you can do with your code, and like the dimensions you can push. I'm sure now you can start to imagine how many different implementations you could do by varying those different dimensions, right? So But let's look at a few simpler examples, places where you can replace one code structure or code artifact with another that are functionally kind of equivalent, but not in their trade-offs. So let's say you have a global variable, right? This variable driver in some game engine, let's say. You could move it into a separate package and make your code shorter because you don't need to state game.driver.fillRect, but you can use driver.fillRect. Yeah. Easy change, but it will change your code design. Then enumerations, like we've all done the IOTA version of it. There's the interface version of it, and there's also the struct version of it. Like, there are, of course, more variations of this. But what makes one better than the other? And when would you use one over the other? The usual example of using an identifier in your method signature, like anybody could put number 4 in there. So, here as well, but like it's at least documented, like what does the function want? Here, you still could put a 4 in it, but not a 4 that came from another place, right? Makes sense. Or you could entirely disallow that behavior. So there's also, let's say, interfaces. There are ways to use interfaces, which can be, of course, replaced with a function callback or multiple, depending on your situation. Or you could replace them with a struct that has a function member. Why would you want to do that? It's an interesting question. Might be helpful in some sort of testing and implementing interfaces. Just a hint. But we could even go to the basics of like, what if you had arguments? Like, how can you represent function arguments differently? So this is the usual version. You could pass in an argument structure, let's say. Or maybe the less common way, if you've used the Geo graphics user interface library, then you've seen this version. Like, why would an API use that approach? Like, what will it do with the performance and why, right? So you've seen a lot of theoretical things of like how can you vary your implementation. Let's look at now kind of trying to implement API. So we'll take a really shallow look at flow-based programming because at some point I was helping Paul Morrison to kind of implement Go version of it and like showing him examples of how you can write it differently. Of course, disclaimer, don't worry about the code if you can't read it. It's later available as well. So at the surface level, flow-based programming looks a lot like coroutines. You have output ports, input ports into components, which are like coroutines. If you translate the input-output ports to channels, then you kind of have something similar to flow-based programming. And I think that should be kind of sufficient in that sense. So let's just throw standard library at it. So we'll create a process group and start a Go routine in it. And we'll get output of uppercase and lowercase string. So what could we modify here? For one, it doesn't handle contexts, right? We want to, let's say we want to tear down the whole process tree. We want to handle context cancellation. So let's make it production ready. Done. Of course, anybody wouldn't be happy with that result. So we can make it simpler by using some helper functions. But now we've already gone through 3 different implementations, right? The question is, like, this seems obviously better, but why would it be worse? Like, for one thing, we've increased our API surface for the library that we've implemented, right? So we may want to be cautious about exposing too much for the end user of the package. So let's put it in a struct. Why not? That's one option. But here we kind of assume that the caller of this or user of this struct needs to populate the fields manually themselves. Or we could do a generics-based processor, let's say. Like throw out all the specialized code for strings to upper, and instead implement one thing that splits the messages apart and then do other components that transform the data. And of course, we've been using the processes group here. What if we implemented a structure to hold all the processes? Like, we will get a lot more control over how the processes will operate, start, and stop. And it will make it also easier for other people to use these networks. Yeah, we've done already a DSL, like, just throw one at this problem as well. Like, we do get now conciseness in our definition of like how things are related, but we also lost our usual coding tools, and Go Please doesn't know anything about it. And yeah, let's look at the component again. We had already something like this. We can use a constructor to populate the fields to ensure that they are correctly implemented. So this could go together with the DSL approach. Or we could put it in the creating the ports inside of the execution part of the component itself. Like, one thing is that now you need to do dynamic port handling on the API side or the package internal side. However, the end user can use a simpler, in a simpler way or a conciser way of the implementation. And like, we didn't need the struct, so let's throw it out all together. We can just use a function with a callback. Or we can use reflection to pass in the arguments, assuming you can find your way through the reflection API and don't make any mistakes. No one has done that, luckily. Or you could do something crazy and put an anonymous struct in as the argument and pick it up via reflection and wire it together with a DSL, right? Why not? Or, yeah, let's make it explicit what are the input and output ports rather than relying on channels. Now that we have introduced like proper ports, we can maybe start doing deadlock detection on a network level, right? That's not tied to the Go deadlock detection. And yeah, how are you feeling? A lot of information. Conclusion. I hope you saw that there's a lot of possibility in how you design your code, and like finding and exercising this design skill is like essential part in getting better in programming. No expert software developer can like come up with ideas like this unless they've practiced their craft and seen many solutions to the same problem. So if you're at any level, you can go try the infinite possibilities exercise. It doesn't need to be the temperature conversion one. If you have a certain problem at a job that doesn't look quite right, you can brute force and find a nice solution to this. I've done this many times, and I have a bunch of other code examples there, which you can read out at your own leisure. I won't torture you with more code. So thank you.